All right, everybody, this is video 1.3.4. It is our last video on compound inequalities, and we're going to be solving lots of different looking inequalities and maybe drawing some different conclusions. Make sure you title your notes with solving other compound inequalities and the video reference number, and we'll get started. I got 3 examples. Let's start with this one. This is an and statement. Because it begins as an and statement, it will end as an and statement, and that's important to include in the final answer. If you just leave 2 inequalities, I don't know if you're talking about an intersection or a union. Very important to indicate that with the word and. But the way we're going to solve these is we actually solve them as 2 separate inequalities. Let's go ahead. I am going to use the inverse method here. So that means that I say what happened to x? X was multiplied by 2. We added 5. We got 7. We subtract 5 and we divide by 2, and x is less than 1. So this simplifies to x is less than 1. The other side, using our inverse operations, we multiplied by a half. And then we subtracted 1 and we got negative 6. So if we add 1, we get negative 5. And if we, I'm going to multiply by the reciprocal here. So I'm going to multiply by 2. That makes negative 10. So x is greater than or equal to negative 10. So I'm going to write this in 3 ways. The first way is to write it using inequalities. And that means x is less than 1 and x is greater than or equal to negative 10. Another way to write this would be to put them in numerical order, and that actually really does help you decide some more things as we move on. So I will rewrite these as x is greater than or equal to negative 10 and x is less than 1. The reason I like it that way is because if I'm talking about an and, I am talking about the intersection. And that means that it must satisfy both. That means it must be greater than negative 10 and it must be less than 1, which means it must be between. Now, had I not rewritten it and I left it this way, I might not be so sure that that actually gives me numbers that fall in between. When I write it where the inequalities are saying greater than this and less than this, I know I'm talking about numbers that are in between. So as I go to put it on my number line, my graph, I use a negative 10 with a closed circle to talk about being included and a positive 1 with an open circle. And because I want them to be greater than negative 10 and they have to be less than 1, then they fall right here. And that then also helps me write my interval notation that says include negative 10 and go up to 1 but don't include it. So let me reiterate that. I think it's a good idea to write them in numerical order because it shows you that you need to be bigger than the one that's on the left but smaller than the one that's on the right. If you need to pause that and rewind it or perhaps re-listen to this, I think it's a good idea. Our next example is an or. When we finish with our or statement, we have to write the word or so that we know it's a union. These have x's on both sides, so I'm not going to use the inverse method. I'm just going to move stuff from the left and the right. But I am going to handle these as 2 separate problems to get started. The first one, I'm going to subtract the 2x to the other side, leaving me with negative 4 minus 5x is less than 1. I'm going to add this 4 to the other side, and I have negative 5x is less than positive 5. When I divide by negative 5, I will also switch the symbol to a greater than. Let's work the other one. I'm going to distribute the 3 here, so that will give me 3x minus 6 is greater than 5 minus x. Now I'm going to add this x to the other side so they're all collected in one place, giving me 4x minus 6 is greater than 5. Lastly, I will add 6 to the other side. Did I say lastly? Of course I've got one more step. And that would be to divide by 4, leaving the x is greater than 11 over 4. So here I've got the statement. And if I were to write it using inequalities, I would say x is greater than negative 1 or x is greater than 11 fourths. But let's reconsider that and think of how we can write that simpler. I'm thinking that if x's are allowed to be greater than -1, or they can be greater than 11/4, well, everything greater than 11/4 is already greater than -1. And because this is a union and everything gets included, I'm going to simplify this to x is greater than -1. This is my final inequality answer, and that's what I need in order to write it on a number line or write it in interval notation. So the second way we write this is using our number line. I like to put the 0 on there. It's exclusive, so it's an open circle, and I shade everything that is greater. Using interval notation, I know I'm going from -1, excluding it, going all the way to infinity. Let's go ahead and look at one more example together. All right, we have another and statement, but let's just go ahead and start. We know we're working two different problems, so let's do it that way. The one on the left, I'm going to distribute the 2. I'm going to combine like terms, giving me 5x minus 2 is greater than 4x. I'm going to kind of do this, might seem a little backwards, but I'm going to subtract the 5x. That gives me -2 is greater than -1x. I'm going to divide by -1, leaving me a +2, switch my symbol, and I write my x. But I don't like the way that looks. It seems backwards to me. So I'm going to flip it and write x is greater than 2. So this is what I'm working with right now. Okay, other side. I'm going to subtract 4. That gives me -1/3 x is greater than or equal to 1. And I'm going to multiply by -3 on both sides. When I multiply by -3, I have to switch the symbol, leaving me x is less than or equal to -3. So let's write those two together. That means that x has to be less than or equal to -3 and x has to be greater than 2. Because it's an intersection, I have to choose numbers that actually satisfy both of those conditions. I can't just pick and choose. Whatever number I want must work for both of those conditions. Let's think about that. I want you to think of a number that is smaller than -3 and greater than 2. There are no such numbers. There's no number that will be smaller than -3 and at exactly the same time be greater than 2. Which means that I cannot write my answer as an inequality. I have nothing to put on a graph, and what would my interval look like? So I'm going to write that there are no such solutions. My graph is blank, and I have no interval. I'll write no such solutions again. So this is how we would represent that there's no solutions for this particular intersection of inequalities. Make sure you go back and rewatch any parts of this that you need to clarify. Take some notes, ask some questions, and go ahead and try the entrance slip on Schoology.